The problem with housing is that we haven't found a way to offshore it to China. If we did, then probably housing would have gotten cheaper, like everything else that we have manufactured there.
There actually are companies that try to do this stuff in China. They will manufacture these modules. But again, to my point about you incur all these extra costs,
shipping and all that stuff.
They have to break them into modules and put them on these boats and bring them over. So it's it's a very sort of niche business.
Welcome to another episode of the Odd Lots podcast. I'm Tracy Alloway.
And I'm Joe Weisenthal.
Joe, you're a homeowner now, right?
Yeah, it's really fun.
Tell me how fun it is. I know you've had a few issues that cropped up basically as soon as you bought your new place.
I don't want to talk about it. Let's move on. No,
this is part of my carefully planned intro.
Yes, I know. Yeah, it's annoying, and you have to deal with stuff. And I may have mentioned on the show one time, actually, I've been lucky, by and large. Mm-hmm. But yes, it was very funny. I think literally the day or 2 days after we closed on my apartment in the East Village, it's like when there was something wrong before, there's just a phone number of someone and
there's
you call
it
the the building still is a super, but the landlord just deals with replacing something. And then I think literally the day after we closed, there was like a window leak. And it's like, wait, is there no longer a number? Do I have to pay for this myself?
So who did you find to fix the window?
Okay, I don't remember. That probably, there is still a super in the building but we had to write a check.
Okay, one of the things that has surprised me about being a homeowner is, I'm thinking how to frame this, but how low tech a lot of housing construction and fixing actually is, right?
Yeah.
So, if there's a leak in your ceiling, in your roof or something, it's literally either you or some guy that you hire going up on a ladder and putting down a few more shingles with a nail gun, right? It all seems very old-fashioned.
What did you think was going to happen?
Well, I don't know.
There's going to be some Unitree robot
there
that crawled up there. Yeah, drone.
No, seriously, it's the year 2025 and we're still putting houses together with nail
hammers
guns
and someone comes with a box and they look through the different screws. They're like, no, this doesn't fit. Oh, I got it. And then they're like, 1 second, I don't have the right screw in. And they go around to in the city, they go around to a construction store. I'll be right back. I'll go, I got this. Yeah, it's still probably the way it looked when we were kids.
Okay, well, anyway, I've been thinking about it because a couple months ago, the Richmond Fed put out this paper and it was all about productivity in housing construction. And the fact that construction labor productivity in housing has fallen by more than 30% from 1970 to 2020.
That's crazy.
So you think about the arc of economic development. Normally there are productivity improvements as we invent new efficiencies and as we invent new technology and ways of making things. That hasn't happened in housing. It's still the guy, showing up with a toolbox.
This strikes me as a really important element of the housing affordability conversation that I don't think gets enough attention, which is it's easy to talk about zoning, and I'm sure there are issues there that need reform. It's easy to, permits and all that stuff. It's easy to talk about financing, et cetera. However, housing is a product and, things get built at a cost and then sold at some profit margin above that. And if that underlying cost keeps going up, and it definitely has in, say, New York City and other areas, if that underlying cost keeps going up, then that is going to push up the cost of housing regardless of what you do on. Now, again, maybe zoning can help with productivity gains, et cetera. Nonetheless, it continues to get more expensive for the actual construction of a home, unlike many other built goods.
Right.
I mean, the issue is that we don't build homes in China, unfortunately. If we did, that would solve the problem. We don't, and maybe we could talk a little bit about why we don't, but maybe one day we will, but that would help a lot.
Well, on that note, I mean, there have been attempts through history to have prefab houses,
that's right?
And some of the old prefab houses that you order from the Sears catalog in the 1920s or 1930s, those are gorgeous. And I would happily live in one of those today. But we should talk about why it seems difficult to build houses, or at least more expensive than some other things. And also why it seems that manufacturing other products seems to get more efficient over time, while housing seems to kind of stagnate.
Seems to not.
All right. So we do, in fact, have the perfect guest. I'm very happy to say we have Brian Potter, who is the author of the Construction Physics newsletter on Substack. I subscribe to this and it's fantastic. He is also the author of the new book, The Origins of Efficiency, and a senior infrastructure fellow at IFP. So really the perfect guest. Brian, thank you so much for coming on the show.
Thanks for having me.
Congrats on the book. origins of efficiency. Are we right in thinking that housing hasn't become that much more efficient of a process?
You are correct. And, the productivity metrics, those metrics are quite complicated, and you can measure it in different ways, and different things show slightly different trends. Some of them just show flat productivity rather than falling productivity. But the general point is, yes, it has not improved, unlike almost every sort of other like physical good has gotten, cheaper and less expensive to make over time. Housing is not like that at all.
And you worked for several years for a prefab housing company or something like that?
Yeah, my background is as an engineer. I worked as a structural engineer for about 15 years. That's what my training is. And that is basically just designing buildings. So I designed parking garages and water treatment plants and apartment buildings and stuff like that. And I had, worked at different facets of the industry. And as you say, it seemed extremely inefficient to me. We're putting up these buildings, we're putting up these houses, on site, by hand, with a guy with a hammer. It doesn't look that different than it did 100 years ago. On my side, it was like we're designing these buildings from scratch every single time instead of designing it once and then making, 1 million copies of it like you do with a car or something like that. So it seemed when I was, much younger, it seemed like incredibly backward and inefficient to me. And then in about 2018, I had a chance to join an extremely well-funded construction prefab startup called Katera that they had, promised like, oh, we're going to come in, we've raised all this money, we're going to change all that, we're going to build buildings in factories, and it's going to be so much more efficient. We're going to be the Henry Ford of housing, and we're just going to sweep away these old methods of building. And long story short, it did not work out at all. They had raised a very, very large amount of venture capital, about like $2 or $3 billion in VC, and they burned through it in a few years and declared bankruptcy.
Oh dear.
And in the aftermath of that, I wanted to understand why had it all gone so wrong beyond just startups are hard.
Right.
Startups have a naturally high failure rate. And whatever operational missteps they may have made. Because I kind of came to believe that there's sort of fundamental thesis that if you build these things in factories like we build everything else, it will get cheaper. I came to believe that was either sort of not quite correct or at least missing a very big piece, such we didn't know specifically what we needed to do in these factories to make the costs fall.
So why are houses, I guess, so customized and not standardized, to your point?
So there's a lot of reasons. One is just, to go back to your point about permitting, there's a very, very large number of permitting jurisdictions in the U.S., something like 20,000 different jurisdictions, which each might have their own, slightly different versions of building codes that sort of need to be enforced. There's just, different building sites are different sizes and shapes and have different, soils which require different things, different environmental design factors, different wind speeds. If you're in California, you need to design for earthquakes. If you're in Florida, you need to design for hurricanes. So there's all these factors that kind of conspire to make the sort of housing market very kind of fragmented, and it's hard to build a very, very large number of like a uniform product. The builders do try to do that. They have somewhat standardized designs that will plunk down in like different developments across the country, but it's quite difficult to do in really, really large numbers.
Talk to us a little bit more about prefab housing specifically, or housing in a factory. What was there have been multiple attempts, and as Tracy mentioned, it's existed for actually a long time, and you used to be able to buy a home from Sears. Talk a little bit about the sort of recent trends in this area, because over the last several years, you've heard a lot of, maybe the last decade, you've heard a lot of excitement about this idea. And as you mentioned, you worked for a well-funded startup. Why now? Like, what's the general thinking? And then maybe we could get into the sort of the gap between the theory and then what happened in practice.
Yeah, so prefab is like this perennially popular idea.
Yeah, perennially.
In home building.
It's always the next decade.
Yeah, it's always the next big thing that's going to come along. And so every, decade or two, you will kind of see these trends, like some big, company will come along and say, oh, I'm going to revolutionize the building with the housing industry with, prefab construction. So, and these attempts, stretch back a pretty long way. So right after, and I became something of a student of these companies that have tried and failed. So right after World War II, you have this company called the Lustron Home Company, which made these very interesting homes, many of which are still around. You can actually go look at them. But they're made of these like steel panels covered in porcelain that turned out to be quite well made and quite durable. But the company went and they got government financing to sort of fund their operation. They had set up shop in this big, what was one time the biggest factory in the world. It was this repurposed aircraft engine factory.
Well, they look pretty cool.
Yeah, they're very neat. I live in Atlanta, and there's some in Atlanta that you can go and look at. But they went bankrupt after quite a few years. In the 1960s, there was this company called Sterling Homex that said, "Oh, we're going to be the next Henry Ford of construction." They went bankrupt in a few years.
I'm sensing a pattern.
Yeah, they were part of this government program called Operation Breakthrough, which was trying to fund. Just again, fund the sort of development of like mass production housing techniques. That program basically failed. None of their companies that they funded, and there were quite a few of them, ended up sort of succeeding in breaking through and creating sort of these mass-produced housing products. So you kind of see the same thing happening over and over and over again, where people are trying to use prefab to like dramatically reduce the cost of construction. And there's ways that you can do that in kind of like a very limited sense. And you can also like build a successful business off of prefab where you're not necessarily trying to compete on low cost, but things like, oh, we can build much faster or stuff like that. But nobody has managed to do what everybody is trying to do, which is like, be the Henry Ford of housing. Okay,
what's the sticking point then? I know you walk through some of the reasons that houses tend to be customized, things like soil types and zoning and regulation, but is that just the story of why we can't have prefab houses that are like across America?
So I kind of look at this in two ways. I think of it as terms of it's very hard to introduce some of these like improvements, these sort of strategies you have for improving efficiency into the construction process without accumulating like more costs elsewhere in the process. And then so at the same time that is, the gains that we've found in terms of like these strategies for efficiency improvement have historically been much more limited than you see in like if you're producing, a car or a light bulb or something like that. And at the same time, we've continually added like more regulations and more difficulty, more administrative overhead in getting stuff built, which is slowly like driving up the cost, even as like we're getting we're not sort of accumulating these productivity improvements.
What's an example of, okay, this on paper looks like a productivity gain that we get in a factory, but then you pay for it somewhere else?
Sure. So, a very simple example, if you're building a car in a factory, you build the entire car, right? It rolls out of the factory line and the car is complete. A building is too big to come out of the factory all in one piece and just, get sent to the job site or whatever. So what happens is you have to sort of build your building in chunks. That's why prefab construction is often called modular construction, because you build it in these modules. And there's different strategies for like, how you break a building into modules, but you're always like breaking it into these pieces. And what happens when you break it into pieces is that you have to add a bunch of extra stuff that you wouldn't have had to add if you were just building it on site. So transporting it down the road, you have to sort of design that to be rigid enough to like not collapse under like the load of like being bounced along on a truck. I used to work at a company that built concrete parking garages, which are built from prefabricated, materials. They build these like big concrete pieces and then drive them down the road. And that was like the design. That was like the controlling design factor, is designing to survive the loads that would incur during transportation. And then once you have those pieces driven down and gotten to the job site, you have to like stitch them together. And so you have all these extra connectors and this extra complexity in attaching them together that, again, doesn't exist in sort of the conventional construction process.
It's kind of crazy to think that whether we're talking about a house or a parking garage that's presumably designed to last for decades, that a very significant factor in engineering is that few hours that it goes down the road. I mean, that's what it sounds like. Yeah, like that's going to last forever, but it has to be there just for that, like that short transport period.
In the case of parking garages, for sure. Yeah. I guess that's why we do have some prefab houses in the U.S. and they're called trailers, because you can actually move them.
Right.
Okay. On this note, How much of this is also maybe a liability question, where if you were producing prefab houses, presumably it's not the company that's putting them together on site. It's usually contractors or someone you hire to do it. And I imagine there's like a disconnect between the contractors on the ground who are putting this stuff together and the company that's building the parts.
There is to some extent. I think that specific liability is not necessarily the biggest controlling factor. What is a big controlling factor, and I've written an essay about this, is that the sort of construction cost, like the cost of in developing and putting up a new building, the sort of distribution of that is extremely fat-tailed and right-skewed. So basically, what that means is that a construction project that goes under budget, that goes really, really, really well, maybe you're like 10% over budget, or under budget. Maybe you're 15% under budget. You can't push down that cost very much, but a project that goes over budget can be 100 or 200 or 300% over budget. So what that means is that there's the risk involved in like introducing some new system that you're not sure really how it works. The payoff is so asymmetrical. It's so much more likely to cause like a massive overrun than to sort of save a relatively small amount, that these sort of builders are like rationally incentivized to not introduce some radically new technology that's going to dramatically change how things go, because the potential costs are so extremely high.
For the sort of maybe dovetailing with Tracy's question, or maybe in the case of Katerra or some of these others, it's like, okay, they have some vision, but because they're not doing the entire thing all around the country, including presumably transport, et cetera, how much is the issue like maybe scale on those ends, experience with that? Like in theory, if you had a really big, experienced on the ground distribution and sort of final assembly workforce or whatever it is, like how much would that help? And how much is the issue that people who work on the ground, et cetera, just aren't doing this full time?
Yeah, that's a part of it is like, this modular construction is kind of a somewhat niche aspect of the construction industry. There are quite a few experts in it that know how to do it, and they do it fairly regularly. And you can usually find them in like any given market, I would say. To kind of, a different point that you kind of alluded to, scale is like another definitely big issue, where it's like, it's not like a semiconductor where you can make 1 million of them in a factory in Taiwan and ship them all over the world, right? That's another big aspect that makes it hard to sort of gain efficiencies from factory production, and goes to what I was talking about, where it's hard to do that without introducing cost elsewhere in the system. The cost of like moving these modules around is so large that it's typically not economic to ship it like more than a day's drive, because then the cost just gets so high. And so what you have, instead of like one giant factory that can like produce, at really, really large scales, these even sort of these modular companies that are doing like large amounts of business, they will tend to be like done in factories like that are spread across the U.S.
So no gigafactory.
Yeah. So like you talk about like trailers, like manufactured homes, which is one area that you can actually see some pretty substantial cost reductions due to various things. Partly it's like they're targeting a lower end of the market and stuff like that. So like the finishes and stuff aren't quite as nice. But if you look at like the way that their business is structured, they have like more than a dozen factories spread all across the U.S., and then each one is serving like a day's drive catchment area. So they're not building like 50,000 houses or whatever in one factory. It's closer to like 500 or 1,000 or something in one factory. And so the economies of scale that you can capture in like a given operation are just fairly limited.
Joe, I have to mention here, we didn't tell Brian that we were going to be talking about housing construction and trailers and all of that. This is all just off the top of his head.
It's, I know.
Pretty impressive.
He sat down and we were like, by the way, can we talk about this? And so,
okay, you kind of alluded to it in your previous answer, but if you were going to choose a manufacturing process that was the polar opposite of housing, what would it be?
Oh, interesting. Probably something like chemical manufacturing, or like, raw material manufacturing, something like, steel or something like that. Because chemical manufacturing, it's, the sort of ultimate form of like a manufacturing process, which I kind of talk about in the book, is what's called like a continuous flow process, where it just like continuously transforms your group of inputs into the output of what you're doing. Just one, continuously without any sort of waiting, interrupting, or batching, or anything like that. It just all flows and is continuously transformed during the process. And that's what like chemical manufacturing is very efficient chemical manufacturing is done. And most other like really efficient manufacturing processes, they ultimately try to sort of converge on something that looks like that. So like the assembly line and like mass production is kind of a way to like get something that approaches like a continuous flow process in these like very complex manufactured goods with like thousands of parts. That was why it was such a huge transformative thing, is because now you could have this continuous flow process, which existed before for much simpler things, but now you could adapt that to like these really, really complex goods like cars. And that's why it was such a transformative thing when it was sort of invented in the early 20th century.
I'm curious, do the economics or the diseconomics of building houses in this way, do they inform your perspective at all on the prospect for small modular nuclear reactors? I mean, there sounds like there are some similarities, especially when it comes to like learning curves, et cetera.
Or the soil of where you're building.
Do you have any views on that industry do you think there's any parallels?
So yeah,
because this is also something that is always the next decade away, right?
Yeah. So I talk about economies of scale in the book, and we're talking about like nuclear stuff. There's like kind of two related economies of scale that in some ways kind of pull in different directions. One is called, and you see this with like other sort of processing equipment, which is I call geometric scaling, which is basically as you build a piece of equipment physically larger, it costs less per unit of whatever it is that you're producing, basically because of like area volume relationships. As you double the volume of something, you less than double the amount of like surface area required to enclose it, and be that like tanks or pipes or stuff like that. So like chemical processing equipment or like power plant equipment tends to get cheaper per unit of what you're producing up to a certain point, and eventually you run into difficulties, and those scaling laws stop working. And this is one reason why power plants, and electricity got cheaper over sort of most of the course of the 20th century, is because we're building these power plants physically larger. But with nuclear, you run into these very nasty diseconomies of scale around the same thing, was because as a nuclear plant gets bigger, the accidents they could have get more dangerous. For like a very small reactor, you can make it so you basically can't have a meltdown. There's just not enough heat in there to like melt through your container or whatever. But for a very large one, the heat gets so large that it ends up being the accidents the risk becomes much, much larger. And so you have to have these like very involved safety systems that maybe you don't need to have on like a smaller reactor. So that is something that maybe points to a reason why these maybe small modular reactors were better. Plus, as you say, now it's sort of the benefits of like getting series production and repeating it over and over and over again. But there is that trade-off, is that you're not getting those geometric effects that traditionally like a lot of this like processing type equipment has relied on to get cheaper.
This actually reminds me of something I wanted to ask, not necessarily about nuclear, but just manufacturing in general. When I think about efficiencies, I think about stuff like, reducing costs as much as possible, maybe just-in-time inventory management and stuff like that. The problem is that if something goes wrong, there's very, very little cushion for protection. And I'm curious, when it comes to efficiency, how do people balance streamlining production with, I guess, building in redundancies in case the worst happens? Yeah,
that's really interesting. And the Toyota production system / lean, which is like a descendant of it, which I talk a lot about in the book, is kind of an interesting balance of these two things, because everybody thinks, lean or Toyota production system, it's like, oh yeah, just in time, get rid of inventories, you don't have all the costs, your factories can be smaller, blah, blah, blah. But really what it is, it's sort of a balance of like, for every factor that you can control, try to like have like the flow be like as smooth as possible, and eliminate all this like, slack and waste in the system. But for the things that like you can't control, you should have your system adaptable to sort of, accommodate that and have sort of a flexibility built into it. So like one example is after the sort of, to bring it back to nuclear, after I believe the sort of Fukushima nuclear accident in Japan, Toyota had it ran into like a shortage of like automotive semiconductors for a while. And they realized that this was like a big like potential like just bottleneck in their process. So after that, even though they're like so focused on, inventory minimization and whatever, after that accident, they basically decided they were going to like stockpile certain critical things that maybe had difficult lead times or something like that. And so they stockpiled like automotive semiconductors. And so during COVID, when all of a sudden these like, there was all of a sudden a huge like shortage of like automotive semiconductors, Toyota for a while was like much less affected by some of these these other car manufacturers, because they had learned the lesson that, in sort of, logistics crunches, these semiconductors can be quite difficult to get. And so, basically people were saying, hey, I thought you were all about like inventory minimization or whatever. But then somebody, some spokesman basically responds like, no, this is basically a standard lean solution where it's, you try to minimize the things, the sort of waste in the sort of areas that you can control. But in the stuff that you can't control, you need to sort of adapt your system to accommodate it.
America seems to have gotten, because I'm trying to understand sort of big picture the trajectories in this country for various things. I joked in the beginning, the problem with housing is that we haven't found a way to offshore it to China. If we did, then probably housing would have gotten cheaper, like everything else that we have manufactured there. But I'm curious, do you have like a theory, because I haven't heard a satisfactory answer, why the U.S. seems to have gone backwards in plane construction? Like, why does Boeing seem to be worse at the job of building an airplane than it was, say, 20 years ago?
Oh, yeah, that's interesting. One point about your housing construction in China, there actually are companies that like try to do this stuff in China. They will like manufacture these modules. But again, to my point about, you incur all these extra costs.
Shipping and all that stuff.
You have to break them into modules and put them on these boats and bring them over. So it's, it's a very sort of niche business. In terms of Boeing, I mean, the standard, story there is that, they went into this merger with McDonnell Douglas.
Yeah.
The finance people.
I don't like the standard story.
Yeah.
And here's why, because I love it so much, right? And so it's like, oh, this is such a good story.
It's too perfect.
It's too perfect. They brought in the finance people. They care about the shareholders too much. Looking at the Boeing stock chart, you would not think this is a company that cares a lot about shareholders, right? They care about shareholders too much. And if they had just stuck with the engineers, I love that story. And because it feeds all of my biases, I'm like skeptical of it.
Yeah. And I mean, a big part of it is just manufacturing commercial aircraft is like extremely hard. There's like a reason that only like right now 2, maybe 3, maybe 4 companies in the entire world do it. Boeing, Airbus, Embraer in Brazil of all places, and then Comac looks like it's going to be the big 4th one. Japan tried for many years to sort of break into the commercial aircraft manufacturing market, and they were after spending like billions of dollars, they were basically gave up just because it was so difficult. There used to be many more competitors in the 1970s, and they sort of got winnowed down one by one. 1 or 2 plane projects that don't pan out, and you're basically out of business. That's essentially what happened to Lockheed. And so it's just a very, very difficult business to sort of be in. And so Boeing is having a lot of struggles right now. But, earlier in the 21st century, you have Airbus having a lot of struggles. They had all sorts of problems. I think on their A380 that they were rolling out, they had like a lot of delays and stuff they had to fix on it as well. So a big part of it is just it's a very difficult business to be in. There's very few people that can kind of really do it effectively.
Here's a question that I've wondered about, and maybe it relates to planes, and maybe it relates to housing, maybe it relates to other things. Like, when you see us going backwards or stalling out, like, here's my question. Could we have some sort of, I don't know if Dutch disease is the right answer, where it's like maybe in the middle of the 20th century, there were people who were working on the floor or working in management at Boeing in a plant somewhere in Washington who are really on the ball and really whatever. And now in that same person in 2025 could make 10 times as much money working for a startup in Silicon Valley or Wall Street, et cetera, that there's some sort of like levels of, awareness or skill or agenticness or whatever, et cetera. And that because we have these other areas where there's so much money that there's like a type of individual who used to maybe work in a sort of construction related field that left that, and then it's changed the talent distribution with
Yeah, I think that's definitely part of it. There's like a, theory in certain circles that we've gotten like, in a sense, too good at like allocating talent efficiently or whatever. So like somebody extremely like talented and smart, it's like, okay, we're going to send you to be a software developer or an AI programmer or work in finance or whatever. And there's going to be the value that you can contribute there is going to be very highly rewarded. But what that means is like there's fewer people going into sort of these other sort of engineering disciplines. I worked as a structural engineer, which is it pays reasonably well, but it doesn't not Silicon Valley software developer salary. Mm-hmm. And I used to sort of tell very young engineers or engineers thinking about in college or whatever, I used to say if you're smart enough to be a structural engineer, you're smart enough to, switch to like software development and make a lot more money and have a much less stressful job.
Yeah.
This is, I think, one part of the reason why, Bell Labs, the very famous AT&T R&D lab that had all, the U.S. invention factory for most of the 20th century, why it would be very hard to have a sort of organization like that today is because the quality of talent that a place like that demanded would be so much more rewarding.
Getting those $100 million meta deals. Yeah.
Somewhere else.
Just quickly on aircraft, it's not like the U.S. doesn't have a history of producing like large scale amounts of planes. And the example that everyone tends to turn to is in World War II, right? We produced, I think, hundreds and thousands of aircraft very, very quickly. What were the conditions that existed back then that allowed us to ramp up that kind of production so fast?
Yeah, I've written about aircraft manufacturing during World War II. The U.S. actually built more airplanes during World War II than have actually been built for commercial purposes for the entire history of aviation.
That's stunning.
It's because we built so many of them, and not that many commercial aircraft get built. I think a big part of it is just the U.S. was just such a huge manufacturing power at like the mid 20th century. We weren't building very large amounts of airplanes, but we were building more cars than anybody else. We were building more machine tools than anybody else. We were making more steel than anybody else. The U.S. was like, the China of today. It was like by far the largest manufacturing country in the world. And so we just had the ability to sort of redirect this manufacturing capability and talent into sort of these new industries. I think that was a very large part of it.
People think about it's maybe, since we're talking about war, we're talking about the U.S. as the China of the 20th century, which is kind of
sounds
funny.
Very Eric Adams, doesn't it? The U.S. is the China of the 20th century.
Is the China. Can there be more than one global manufacturing hub? Because when you think about economies of scale and you think about network effects, it's like how many other cities in the U.S. have tried to be the San Francisco or the Silicon Valley? And you've really never replicated. When you think about sort of agglomeration and network effects, et cetera, and you think about what it takes for manufacturing, and you think about, okay, now in the 21st century, China is the China of the 21st century, and you think about the efforts at U.S. sort of reindustrialization, because there's all this angst about whatever, we can't build advanced things. It's like, well, can we have advanced things if we don't also do the simple things like washing machines, et cetera? Like, can there be more than one in the world at any given time? Or does market logic sort of dictate that one will be the powerhouse?
Yeah, that's a really interesting question. And so my first answer is that I don't know. Okay. And the second answer is, I think historically kind of what you see is that like transportation costs have kind of been something of a barrier to preventing one country from like just dominating production of a certain thing. So even like when in the 80s and 90s when Japanese like car manufacturers were like trouncing the U.S., it was still so expensive to like ship them from Japan or whatever that it was still valuable to like set up local manufacturing operations. In the U.S. They still wanted to build their plants in the U.S. to sort of make it not so expensive to sort of transport these things. So I wonder if like as transportation has gotten more and more inexpensive, I wonder if that has like shifted the logic of this, and you can have this sort of like concentration of production in a way that maybe it wasn't didn't quite make sense to do before, when like these transportation costs bit a little bit harder. I don't know, but it's an interesting interesting question.
Just going back to Boeing for a second. So we talked about the classic story of what went wrong at Boeing, and it's that tension between, I guess, the manufacturers on the ground and the executives in the boardroom who are trying to cut costs and boost the share price and things like that. Is that like a trend or a thing that you tend to see across manufacturing, where the manufacturers are constantly under pressure from the finance execs on the top? Or are there companies out there who have like cracked that relationship where finance and manufacturers, engineers kind of work together?
Yeah, I think, the pressure definitely seems to be, constant pushing to find, lower costs, and which is one reason why, the trend in the second half of the 20th century was like just outsourcing, finding new places to sort of make this stuff that is, cheaper. I talk about a Nike in the book, and there's sort of an interesting path that Nike takes where it's like constantly hunting the cheapest sources of labor, where they start out manufacturing somewhere cheap, right? They start out manufacturing their shoes in Japan because it's much cheaper to make them there than in the US. But then as Japanese labor starts getting more expensive, they move their manufacturing to Taiwan, and then from Taiwan to China. And I think now it's almost all done in like Vietnam and Indonesia. So it's just constant hunt for the new sources of labor. And you see that just broadly across industries, like where New York, which used to be sort of a garment manufacturing center, but as New York labor got more and more expensive, they moved, first, out of state into New Jersey, and then to the South, and then overseas. So there's just constant pressure. But then there's also companies that have, like, I think, bucked that trend and been, more like, we think the returns from like investing in our workforce and its capabilities is going to be valuable enough that we're going to do it. I think, a company like Nucor, which is a steel company in the US, which is like very sort of famous in terms of like how it invests in its workforce and things like that. And they've been extremely successful in doing that. They grew from nothing to being the largest steel manufacturer in the US, I believe.
That just reminded me something that I really want an answer to, and you might actually have it. Why are communists obsessed with steel?
Oh, good question. I just think, I think in the, sort of the early 20th century, late 19th century, these were the things that like represented like industrial might and like successful country or whatever. And then they never kind of like got out of that sort of framework or whatever. So like one criticism of the Soviet Union was that they were really maybe good at sort of building these like industrial things, but they never managed to build like a successful computer or anything like that. They couldn't get out of their sort of mindset. It's sort of maybe easy to measure like success in terms of like output or whatever. Yeah. It's just like relatively simple commodity that you can
right, this physical thing you can point to. Look at our stockpile of steel.
The more tons you have, the better you've done. With more complex things, maybe it doesn't, it's not maybe so amenable to sort of this like top-down management style. I don't know, but those are some of my theories.
Let's get back to housing, because when we started and Tracy was talking about the fact that, even setting aside the prefab stuff, and you were talking about it, the actual on-the-ground, one-off, et cetera, home building, it's arguably, by some measures, productivity has gone backwards, or maybe it's flat. Setting aside like prefab, you mentioned zoning, regulations, et cetera. What is your view for why just the normal sort of style of housing construction hasn't gotten any more efficient over the years?
Yeah, and so I talk about the kind of this in the book. This goes to sort of the main thesis of the book, where I sort of break down. There's a specific points of intervention that you can do in any process to make it cheaper. I've talked about these a little bit. Economies of scale. You can make more of what you're doing. You can introduce some like fundamental new technology. An example of this, to talk about steel, like the Bessemer process for making steel, which like fundamentally was simpler and took less inputs than the processes that came before it. So I kind of break down these different factors in the book of like what you need to do to make some process more efficient. And if you can do those things, your process can get cheaper and you can sell it for less. And if you can't do those things, you can't make the process any cheaper. And all those basically paths to improvement are either like blocked or like very difficult to do in construction. So we talked about economies of scale. That's a big one. We talked a little bit about risk aversion. It's hard to kind of introduce like fundamentally new technology. The cost of your inputs is like a big one. The materials and sort of energy and labor that you're using in the process. Those costs are hard to sort of reduce in construction. It's very hard to make building materials any cheaper than they already are. I'm kind of in dollars per pound or dollars per like cubic foot terms. They're basically as cheap as anything that civilization produces. It's not easy to make those things cheaper than they already are. It's also hard to use less of them in a way that doesn't make the house worse. And so all these paths are that you have, that a process can take advantage of to sort of get less expensive. They're all very difficult to do in construction.
I just remembered another question that I always want to ask people, and I feel like you will also know the answer to this one, which is, why does America build houses out of wood frames and timber versus the rest of the world where they tend to use a lot more cement and concrete?
Yeah, so the wood, U.S. has historically built a lot of stuff out of wood because we had such huge supplies of it. In places like Europe, a lot of those, large forests got cut down way earlier, and so they just didn't have the huge supplies of wood that the U.S. had, and so that kind of shaped how the technology developed. Because wood is very, very inexpensive. You can use it. It's a very inexpensive way to sort of build a house. They do actually do sort of still timber frame construction in other parts of the world. It's maybe not quite so dominant, but it's like used in the UK. Germany uses it. Germany actually, they have some like prefab construction startups that are using like timber panel construction. It's used in a lot of the Nordic countries that have a decent amount of supply of wood. So it's not like unheard of. It's most dominant in like the US and in Canada, but in other places that have a decent amount of wood, they tend to use it as well.
Should we completely give up on prefab or major efficiency gains in housing in the U.S.? Or like, are you still open to, is it just there's not a way to do this? Or is there still out there some magic bullet that's waiting to be found?
You should tell us what happened to the company you were working for as well.
Yeah, so they raised a huge amount of money. They basically, after raising like several $1 billion and building all these factories to like mass produce housing, they basically ended up going bankrupt. Partly because they were never able to sell enough of these buildings that they were trying to sell. It's very hard to like pivot your operations when you're like invested in all this like physical infrastructure. And then COVID, was kind of the final nail in the coffin. I'm not totally, I'm not completely pessimistic. I mostly just think if you're going to sort of try to change the industry with prefab, you need to have a very strong thesis as to what specifically this time is different and why it didn't work previously and what is now has changed, what constraints have been relaxed that will make it possible now. And I don't have any number of things could change that. Certain materials get cheap enough, it gets like inexpensive enough to build a factory. Any number of things. I think that very, very good automation and robotics have a good chance of changing this, just because, even if nothing else were, I'm not the most creative person in the world. I can't necessarily come up with like some amazing new way of putting a house together. But even if nothing else works, if you have like a robot that costs $5,000 and like can basically duplicate, 95% of what a person can do, that would effectively solve your problem, right? You drop in these robots, and you build, whatever it is that you're trying to build using this robotic, much less expensive labor. And I have a sort of a vignette in the conclusion of the book as to what that might look like in the future.
So we could get the drones that go up on the roof and fix leaks and stuff like that.
Anything's possible.
All right. Brian Potter, thank you so much for coming on Odd Lots. Really appreciate it.
Thank you. It was great to be here.
Yeah, that was a lot of fun. Thank you so much.
Joe, that was a really fun conversation.
Yeah, that's really fun. I love Brian's stuff, and I feel like
good.
One of those conversations where both of us could just ask a bunch of questions we've been meaning to ask for a long time.
I did read, apparently his new book, The Origins of Efficiency, has a bibliography that's like 600 items long.
Amazing.
Which is incredible. To think about him poring over like 600 different reference sources.
We didn't get into it in this conversation, but he's written about his process before.
Yeah.
Of like, okay, I want to learn about some new industry like fighter jets or whatever it is, and how he goes about diving into it, et cetera. And yes, it seems like
as people who talk about stuff, I should probably read that.
Yeah, totally.
Speaking of which, I am very proud of us for not mentioning the word deflator at all in a conversation about housing productivity, housing construction productivity. I should just mention that Richmond Fed paper that I talked about in the intro. So their conclusion was sort of an amalgamation of all the factors that we talked about in this conversation. So they basically said they think that smaller construction firms have reduced incentives to invest in technological innovation because you don't get that economy of scale. And in fact, if you look at areas with stricter zoning laws and things like that, you can see that they actually have even less construction productivity than other areas. Yeah. Again, because like the incentives and the economies of scale just shrink and shrink and shrink. So that's kind of interesting.
It would be interesting. Something I was sort of curious about during that is I wonder if you just look at one market where it's very flat and dry. I was thinking about Arizona or something like that. Like, have they seen productivity gains there? Especially thinking about some of our conversations with, say, Chase Emerson, where, okay, there's one master plan and a bunch of houses. We all have driven by them that all look exactly the same. Do you get those learning curves, at least on some limited effect? I would be curious about that.
But I feel like to some extent that is the story of the Sun Belt states, right? You have cheaper houses there because you can have these big developments.
But it's scale. It's scale all the way down. And so I like that point that he made, which is that you can identify the sources of efficiency gains. Scale is one. A scientific breakthrough, such as the Bessemer process in steel, is another one, et cetera. But they're not magic. Right. They're not just going to emerge. You probably get some efficiency gains just from, repeatable process or a sales labor force that gets better over time. But by and large, you're not just going to, the silver bullet isn't going to come out of nowhere. Yeah. And especially the fact that there are all these sort of very fundamental reasons why you can't have scale, or even the factories that build the prefab homes cannot be a gigafactory due to distribution costs. Well, you see why you run into that constraint.
That's what I was thinking. It's like the tyranny of physics, basically. Yeah. Like, even though we have all these technological breakthroughs, transportation has gotten cheaper over time, you're still limited by geography and the realities of, real world objects. And I guess that's why you can have gigafactories for something like chips, which are really easy to send abroad. They're tiny, but you can't do it for something large. And
I really am curious about the point about talent distribution and whether they're, in the 1950s, for a certain type of talent, the Boeing factory was the best place they could have gone.
Well, that was the cutting edge.
And that was the cutting edge. And now the Boeing factory still more or less resembles the Boeing factory of the 1950s with maybe similar pay scales, and so forth. I'm sure the nominal pay has gone up a lot, but there are just so many great opportunities to make 10 times or much more money elsewhere. And so the sort of remaining talent, whether there's some, whether that has an effect on how well it can operate, I'm very interested in.
You know what Boeing needs?
Go on.
They need like a Mad Men style TV series that glamorizes the aircraft manufacturing process and gets people interested in it again.
Yeah, no, that's a really good idea.
All right, that's a free idea for Boeing. Shall we leave it there?
Let's leave it there.
All right, this has been another episode of the Odd Lots podcast. I'm Tracy Alloway. You can follow me at Tracy Alloway.
And I'm Joe Weisenthal. You can follow me at The Stalwart.
And if you enjoyed this conversation, then please like, comment, or subscribe to the channel.
Thanks for watching.